I'll get this eventually. Okay, so let's say I have this example here. It says, calculate the arc length for each of the following. Okay, I've got a radius here. I've got a central angle of 230 degrees, and I have to find out how long this arc is. So let me calculate the circumference and then multiply that by 230 per 360. 230 degrees, so 230 over 360. So let me write it like this. I'm going to say circumference first. Circumference equals 2 times pi times the radius. Right? 2 times pi times the radius. Okay, if that's true, then let me plug in the numbers that I know. I know that the radius is 62 meters. So I can plug that right in. That's the part of the formula I know. And then I get out the calculator and I calculate what that is. And I say 2 times pi times 62. It gives me this number, 389.5574, blah, blah, blah. If I'm going to round this to 2 decimal places, I'm going to write 389.56 meters. 389.56 meters. So that's my circumference so far. And if I want to get the arc length, that's the dark black line around here, then I say, well, it's like this much 230 per 360. So I'm going to say 389.56 times 230 per 360. Right? So that would just look like this. I say 389.56 times 230 per 360 equals my arc. So then I get out my calculator, which still remembers exactly how far 389.555, even though I wrote 389.56, it knows more exactly what that distance is. So I say, let me multiply that by 230 over, over 360. And that gives me my arc length, 248.88 meters. So I can write that in here. Arc equals 248.88 meters. Assuming that's right, let me make sure I've got the right answer that my calculator said. 248.88, good. Okay. Now, one thing that you guys will need to know is that, like I said in the previous video, a lot of what you'll be seeing in this unit is learning how to do this forwards and learning how to do it backwards. So sometimes it's pretty straightforward like this. You just get the circumference, multiply it by the number of degrees over 360, and that'll give you your arc. But I want you to really know this in a formula that'll work in any situation. So here's the formula that I want you guys to be able to use, right, for when things get a little more complicated. It's like this. You say that the arc is equal to, let's say, the number of degrees in the central angle. I'm going to say x degrees divided by 360, right? And really what this means is it's a proportion. The proportion is that the arc over the circumference is the same proportion as the central angle divided by 360. And this makes sense, right? All this is saying is that this much over this whole circumference, right? The arc here, I'm saying the arc over the circumference. So this whole arc divided by this whole circumference is exactly the same as this angle, 230, over all 360 angles, right? 360 degrees. Saying this whole arc divided by the whole circumference, arc over circumference, equals x degrees, in this case 230, divided by 360. So let's do the same problem. Actually, we'll do this problem, but we're going to set up the same idea, except we're going to write it using this formula here. We'll actually end up doing the same thing. But this one works much better when you're trying to do it backwards, so I want you guys to be able to use this. Okay, so I know that my formula up here, which I didn't draw very well, but you guys get the idea. Arc over circumference equals x over 360. So now let me plug in the numbers that I know. I don't know what the arc is. I do know what x is. It's 140. So let me plug that in first. I know that I can say, I still don't know what the arc is, but I know that, so what was the number in this case? Oh, I didn't write it down. 140 degrees. I know that the arc is equal to 140. That's the top part of my equation here. Arc over circumference equals 140 over 360. I know the number I can put in here right away is going to be 360. That's not a problem, right? So these are the things that I know. I know x is 140, and I know 360 is 360. And I don't know what the arc is, and I don't know what the circumference is yet, but I know that the circumference is 2 times pi times the radius. So that means I can write in 2 times pi times the radius right here. Let me do that. 2 times pi times the radius, which is 111 in this question. Right? So now I've got all the numbers in that I want. And really the only thing that's missing here, the only thing I don't know is arc. Pi looks kind of like a variable here, but it's, remember, this is just a number, 3.14159, blah, 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 blah. Okay. So if I have this whole thing set up and I've only got one unknown, I'm going to be able to solve for the arc here. First, let's simplify down under here. 2 times pi times 111. 2 times pi times 111 is 697.43. 697.43. So already I could simplify that. 697.43 centimeters is down here in the bottom left. Right? And then over here, I've still got everything is the same. Right? Got my equal sign. I've got 140 up in the top right here. Down here, I've got 360. And then I've got a couple of fraction lines. And I'm just trying to find out what the arc is. At this point, I'm going to use just A, because I'm pretty lazy at this point. So now you see the way this is set up. All I've done from here to here is I just simplified the bottom part to get 697.43. And I've just replaced arc with A. And now if you're looking at this, this is exactly like the kind of thing we were doing back in October. This is just, you can call this fish method, you can call this cross multiplication, but it's just going to be, let me take 697.43, multiply that times 140, divide by 360, and that'll give me A. So let me write that out. Right, that's all I'm going to be doing. A equals 697.43 times 140 divided by, I don't think they have a divided by button here. Let me just do this for now. Divided by 360. And now that I've written out the operation I'm going to do, which is just, this is just another way of writing out what happens when you do the fish method. 697.43 times 140 divided by 360 gives you A. Now I just do that on my calculator. I take my number, which is still in there, 697.43. I multiply it times 140, and then I divide by 360 to get my answer. 271.22. 271.22. So the arc, equals 271.22 centimeters. Don't forget your units there. All right. So far, so good. Now in this one, sometimes when you see something like this, you can be a little bit thrown off. You say, well, this is very different from this problem and this problem. It's not. Just the diagram is a little less complete. You don't see the rest of the circle, but you can still figure out, okay, I only want to figure out, like I can imagine the rest of the circle here if I want to. I can even draw, I could say to myself, well, there's like a whole big circle going around here. Obviously, it's not a very well drawn circle, but you get the idea. So I still use the same formula. I still use the same setup. I say to myself, let me get, like here I could say arc. Now you guys see why I type most of the time. Arc over circumference equals x, which is the central angle, 24 degrees over 360. And in this case, since I know that I've got a radius here, this is a radius of the circle, then I can use that to get the circumference. I do 2 times pi times the radius. Remember, that's the formula for circumference. 2 times pi times the radius. So I can rewrite this. I can say, let me go back to typing so I don't take up the whole screen with my awful grade 1 handwriting. Arc is equal to, it's going to be 24 over 360. So arc is the circumference, which is 2 times pi times my radius, which is 3.6 meters in this one, is going to be equal to 24 over 360. Right? So it looks like this. Oops. And then just so you guys know what I'm talking about, put some lines in there. So arc over circumference equals the central angle divided by 360. And now this just becomes a question of calculation, right? I got to simplify this first, then it's going to be fish method. This times this divided by this gives me the arc. Let's write that out. 2 times pi times 3.6 is where I start. 2 times pi times 3.6 gives me 22.62 meters. I've got 22.62 meters. And then I've set it up now so that I can just do the fish method. So I can say, all right, if arc over 22.62 equals 24 over 360, then this times this divided by this will give me arc. Right? So I can say arc is equal to 24 times 22.62 divided by 360. Now you might be saying, well, sir, shouldn't the fish method be 22.62 times 24 divided by 360? Yeah, you'll get the same answer. But maybe to make it less confusing to you, I'll put them in that order as well. But you'll see if you punch the numbers in, you'll get exactly the same answer. All right. So if I do this calculation, I take the number that's still in my calculator, I multiply it by 24, and I divide that by 360, then I'll get the length of my arc in meters, 1.51 meters. Put this in here. Arc is equal to 1.51 meters. And that is my final answer. So I can put a nice circle, or in this case a rectangle, right around it.